my variable cost is gonna increase less than proportionally if I increase y. Or, okay, if I increase my output level by 10%, my variable cost is going to increase by less than 10%, which is good, right? Then you want to increase your production. Okay, which corresponds to here. If you increase your input by 10%, your output increases by more than 10%. It's the same. By increasing more output, it's the same as you save more money in terms of input. So in stage 1, this epsilon is a number between 0 and 1, but this elasticity is greater than 1. Okay, it's kind of reciprocal between the two concepts here. Okay? Stage 2, where marginal cost is above the average cost. So this elasticity is greater than 1. Okay, but we don't have stage 3. Again, in stage 2, that means beyond this point here, okay, where the elasticity is equal to 1, marginal cost is equal to average cost. Okay, beyond that point, if I further increase my output, my variable cost is going to increase faster than the speed at which I increase my output. Okay? So there's pretty obvious correspondence between this new elasticity and this factor elasticity we defined earlier. Okay? Indeed, there's in a one variable factor setting, there's this relation. The inverse of this new elasticity, variable cost flexibility, is the factor elasticity we defined earlier, which is really not surprising given the shape of the two functions. Here is convex, it becomes concave here, and it's concave becomes convex here. Okay. Well, if this is still not very clear, let's just try to prove that. Let me just first use this example, okay? Because the Cobb-Douglas, what is the factor elasticity given the Cobb-Douglas function? Alpha, right? Remember Cobb-Douglas function, elasticity is alpha, okay? Now I'm gonna get I got my variable cost function, this. Okay, I'm gonna get my variable factor elasticity using this formula. I take log of my variable cost function, and take the log of y. Okay, then take the partial. Look at here. Log C now is equal to log R plus 1 over alpha log y minus log A. Is that right? If I take log on both sides of this equation, log C, the log of my variable cost, is equal to log R plus log y over A power raised to 1 over alpha. I can pull the 1 over alpha here to get this, correct? Okay, now what is the variable cost flexibility?
The inverse of your...
Is the partial of log C with respect to log y. You take the derivative of this with respect to log y, which is inverse of alpha. And alpha is the elasticity, factor elasticity. Okay, this is just an example to show that statement is true. Well, later on we'll talk. Remember, there's a homework question. I asked you to look at this alpha, the elasticity. the returns to scale. But I ask you, whether the industry exhibit increasing or these economies of scale or economies of scale. Usually, these economies of scale are discussed in the cost setting. When you talk about the cost of production, okay, if you increase the size of the firm, your cost will be lower. Your average cost will be lower. Then you have economies of scale, correct? So there's a perfect matching between return scale and economy scale. It's two coins of it's the two sides of the same coin, okay? Which can be seen here, okay? In this area, along in stage 1, if I increase my size, okay, my cost is going to decrease. So there's economies of scale, okay, which is in this stage you have increasing returns to scale, correct? So economies of scale is equivalent to increasing returns to scale, okay. Then beyond this point, okay, in stage 2 you have diseconomy of scale, okay, because your variable cost increase more than proportionally to the increase in output. If you double your size, okay, your variable cost is gonna more than double, okay, which corresponds to increasing return scale in the production function. So that's why I said, when you ask the question, economies of scale, diseconomy scale, actually they are equivalent to the return scale concepts. Okay, this is we have one variable factor, correct? But if you had two variable factors, okay, this is a relation extended to this. The inverse of this variable cost elasticity is equal to the sum of the two partial elasticities. Okay. And remember, the sum of the two partial elasticity is the degree of return scale. I don't know if you I didn't talk about this, but the textbook does give a formal proof of this. If you have a homogeneous function, you get the partial elasticity. You add them together, you get the degree of return scale. Okay. So I'm not going to prove this, I guess, but the intuition is more important. Okay, the cost function is determined completely by the production function. Well, before I go on, I guess any questions? We need to digest all of this information. I know when we are dealing with general functions, with a lot of variables, it's not very intuitive. Any questions so far?
Can you say that one more time about this economies of scale? If the firm doubles its size, what were you saying?
A firm is operating at a level where a level of economies of scale. That means if you double the output level, okay, then the variable cost is gonna less than double. You save some cost by increasing size. Okay. It's operating at this economy scale. That means if you double the firm size, okay, the variable cost is gonna more than double. Okay, so it's not good to increase size. That's why